what we're going to talk about right now is the business end of photosynthesis, and this is when we actually make sugar. All we did in the light-dependent reaction was making the batteries, which will run the Calvin cycle. We also happen to make a little waste product called oxygen, which has some importance to us as living beings. But we're going to take the NADPH, the live battery, and ATP, the live battery, over here to this board, and we're going to run a series of chemical reactions that take place in the stroma. So to begin with, there is a chemical that hangs out in the stroma made by the cell called RuBP, RuBP. And RuBP has an affinity. In other words, it really likes to touch carbon dioxide. So carbon dioxide comes in the stomata from the atmosphere. There's a cloud, here's some birds. And when it does, it combines and forms an intermediate chemical compound. I'm not even going to give you the name, it's just not that important. This intermediate is not terribly stable, and what it does is it turns into another intermediate as it tries to rearrange itself and become stable. Then what happens is some of the compounds that we made over here, the live batteries, ATP, actually come in and interact with this chemical B. And of course, once they leave their energy behind, they're now low energy molecules. And that changes them into another intermediate chemical. Again, we're not going to name them. You just need to know that they change because of energy that we created in this first step. C now is RuBP plus CO2 after it's been rearranged. And it rearranges further because of this ATP. And out of the bottom of this equation eventually drops sugar. C6H12O6. This is a type of sugar called glucose. Then C, chemical C, is further rearranged by the addition of energy. We will put NADPH on it. And of course, when it becomes low charged, it becomes NADP, a dead battery, and it turns chemical C back into RuBP. A couple things I want to point out is that CO2 comes from the atmosphere. It joins RuBP, and we end up with RuBP, which means that sugar then must be made from the carbon that you get from the atmosphere. That's the only place it comes in. We started with this, we end with this. The only thing we've added is this. The only thing we've taken away is this. So this came from CO2. Glucose can be modified and be turned into protein, lipids, or any number of other biomolecules. That's why plants are so impressive. These dead batteries, by the way, now that they've lost energy, can be returned to the thylakoid and charged up through the light-dependent reaction once again. And nothing's wasted.